So MapReduce is misleading term, and it is used in the context of resource as well as job management and also for development. So typically developers say that I'm writing MapReduce programs. Administrators will say that we use MapReduce as a framework to submit the jobs and process the data. So it's a misleading term, and depending upon the context, the meaning changes. But as this is admin course, we will be more focused on resource and job management rather than MapReduce development. Okay. So there are two ways for job management. One is MRV1 or Classic, and the second one is MRV2 or Yarn. We will focus on Yarn as part of this course. Actually, we will focus on both, but Yarn is more important because it is future, and Classic is legacy. Okay, this slide is a little bit incorrect. I will be covering both because most of the production clusters are still running Classic, so it is very important that you understand Classic as well. So this is the high-level architecture about MRV1 or Classic. So so far, yeah, in HDFS, what we have seen is it's a master-slave architecture. Okay, so it's a master-slave architecture. You have a name node, you have a secondary name node which is helper to name node, and then you have bunch of data nodes in the cluster. Okay. So when you to process the data, again, so yeah, when it comes to HDFS, you have daemon process called data node on all the slaves, name node on master, and the secondary name node as helper. But similarly, to process the data also, we need to have a daemon process which can coordinate with each other and process this data in distributed fashion. Okay, so that is for that purpose, even MapReduce have the daemon process like we have seen in HDFS. HDFS have, so let me go back to the cluster and then I will explain. So if you click on HDFS and if you click on instances, you have 1, 2, 3, 4, 5, 6, 7, 8 data nodes at this time. Okay, 8 data nodes in the cluster. Okay, but there is only one name node and one secondary node, name node in the cluster. It is not showing up name node and secondary name node here. Let me see. Home, HDFS, instances. Yeah. So you have name node and secondary name node. One of them. These are masters. And you have 8 slaves which are data nodes. Okay. Similarly, even for processing, you will have slaves and masters, and depending upon the version you use to process the data, you will see different backend daemon process. So if you are using Classic, the master is termed as job tracker, and the slaves are termed as task trackers. Okay. But the actual processing will be done by transient daemon process called mappers and reducers. Transient means temporary, whereas job tracker, task tracker, name node, data node, they are all persistent daemon process or permanent daemon process. They will be up and running all the time on the cluster to keep track of resources and all those things. But there will be additional backend process or daemon process. Daemon process means the process which will be running in the background all the time. Okay. When we actually talk about daemon process, by default we are talking about persistent or permanent daemon process which will be running in the background all the time. So with respect to HDFS, they are termed as name node and data nodes. With respect to MapReduce or processing the data, depending upon the framework you use, the daemon process names will change. So in case of Classic, we have job tracker as a master and task tracker as slaves. When we submit jobs, there will be additional transient backend process that will be running. which will actually process the data. So task trackers and job trackers will only control these mappers and reducers. They themselves will not process any data. Okay, only mappers and reducers, whether you use classic or yarn, only the mappers and reducers will actually process the data. And this persistent daemon process will only control them. And when it comes to MRV2 or yarn, you will have a resource manager, which is a master, and a node manager, which are slave daemon process. And then there are mappers and reducers and app master. I will talk about those things when we get into those things. For now, just understand that there are two frameworks, MRV1 and MRV2, and mappers and reducers are transient daemon process or backend process, which will actually process the data. And there are two frameworks to control them. One framework is called as MRV1, and the persistent daemon process job trackers for masters and task trackers for slaves. And if it is yarn, the resource manager is the master and node manager are the slaves. Just to understand the terms, we will get into the details later. Okay, so when it comes to Hadoop 1 or earlier versions of Hadoop, we have only MapReduce. We don't have yarn. So most of the Hadoop clusters will be using the MRV1 Classic. But when it comes to 2, they made yarn as default, and MapReduce can use yarn for the resource management. So if you look at these pictures, right, where we are talking about frameworks to process data, when it comes to earlier version, MapReduce will do both cluster resource management and data processing. It does both. Whereas in yarn, the cluster resource management will be done by yarn, and MapReduce will be used for data processing. It will be a little bit confusing. Don't worry about it at this time, and you will understand. But one thing you need to understand, one thing you need to keep in mind at this time is, if you are using Hadoop 1.0, you will be dealing with MapReduce Classic, and if you are dealing with Hadoop 2, you will be dealing with yarn. And I will talk about differences in the next session, and then you will see the purpose of yarn in more detail at that time. Okay, so MRV1 architecture, it is also called as Classic. It is a job management tool which do not keep track of resources used by non-MapReduce based tools. So if we go back to the presentation which we have discussed in the earlier sessions, okay, about Hadoop introduction. As I mentioned to you, this diagram is very important. Okay, there are MapReduce based tools like Hive, Scoop, Mahout, Pig, Oozie, Flume, and also non-MapReduce tool Presto, HBase, and Impala. Okay, one of the major drawbacks using MapReduce Classic framework is that it only keeps track of MapReduce based tools. So if you have both HBase and MapReduce programs running on the same cluster, as MapReduce do not keep track of the resources used by HBase, it might make wrong judgments, and you can see performance issues in the Classic framework. So that is the major difference between MapReduce and yarn. MapReduce only keep track of MapReduce based tools, resources used by MapReduce based tools, whereas yarn can be used by both MapReduce and non-MapReduce. So based upon the usage of each other, it can make better judgment in distributing the resources. Okay, and the daemon process are job tracker and task tracker. So let me see. Yeah. So the daemon process I have, as I explained earlier, are job tracker and task tracker, and the parameter files are map.site.xml, and there will be a job tracker web interface to monitor using web UI, and also we'll look into log files. So if you follow, even in case of HDFS, we explained similar stuff. There are daemon process, there are parameter files, there are Apache web interfaces, there are log files. So if you, why I'm spending so much time in Hadoop core competencies, they are HDFS and MapReduce are kind of heart to the entire Hadoop ecosystem. So once you understand these things, you can follow the similar methodology to understand any tool, whether it is in this list. Whether it is in this list or not, you can follow the similar approach, and then understand the architecture, try to understand what the parameter files are, where the log files are, and if you understand the purpose of it, deploying it will be pretty straightforward, and you can follow the same pattern for almost all the software products, not just Hadoop ecosystem. Okay. So now we will set up MRU on our Classic, and we will see how we will configure slaves and masters. We will see parameter files. We will understand important parameters. We will validate whether it is configured properly or not. We will verify logs and all these things. Okay. So configuring slaves and masters. So again, go to Home in your Cloud Manager, click on this button, and now we are adding a new service. So click on Add a Service, and we are actually adding MapReduce. So if you want to deploy yarn, you just have to select this one. But in this case, we want to see the old framework as well. So first, I'm starting with Classic. And if you read, so before doing anything, you should read the information they have provided. That is one of the best practices to be a good administrator. Apache Hadoop MapReduce supports distributed computing on large datasets across your cluster. Yarn included is recommended instead than this one. MapReduce is included for backward compatibility. So this is mainly for backward compatibility. But by default, the recommendation is to use the yarn. Okay. But in this case, just to understand what it is, we are configuring the Classic, and then we will configure yarn. Click on Continue. And the main thing that is required is HDFS. That's why it is showing us two options. In this case, we'll use Zookeeper also wherever it is required in future. So I'm just selecting the first one. And then if you see, the task trackers are automatically picked up based upon the data nodes. So let me go to Novi Sync. I'm going to the Cloud Manager in a second window, and I'm clicking on HDFS. Okay. And if you click on Instances and click on Good Health, okay. So, and if you sort the names, our data nodes are 7, 9, so 7 and 9 through 15. 9, 10, 11, 12, 13, 14, 15, and 7. 8 is missing because it failed in the last class. We will see about it later. So even here, if you see, it picked up 07 and 09 to 15. So wherever data nodes are running, you were supposed to start the task trackers. There is a reason for it. We will see it later. But just understand that data nodes and task trackers are co-located. So if you think about the important concept which I have discussed earlier of data locality, processing and storage needs to be co-located wherever it is required to get the data locality implemented. For that reason, your data node, which is for storage, and task tracker, which is for processing, have to be running on the same nodes in the cluster. Okay, that is the recommended. Is it strictly enforced? No, it is not strictly enforced. You can actually select on, click on this and select all nodes, and it will deploy on all the nodes. but in this case we are doing this. Instead, you can even use custom, and you can add more nodes which are not having data nodes and still start the task tracker on that. But that is not a good practice. You should only start task trackers on the data nodes that are on the nodes where data nodes are running. Okay, and job tracker typically in a production cluster, job tracker will not be on the servers where your name node or secondary name node is running. Okay, it should be on some other node. In our case, 500 is a gateway, and 502 is a name node. 503 is secondary name node. So I don't want to use these three. So I'm choosing 504 for the job tracker, which is a master for processing. Okay, 1 minute. I will get back to you on that. So if you see here, you can hover on that, and there will be a tooltip which will be explaining what it is. G stands for gateway, and we have installed gateway on all the nodes. DN stands for data node, NN stands for secondary name node, SNN stands for secondary name node, NFS is NFS gateway, which is not required. I will be deleting those things. So Hadoop supports multiple file systems. One of them is NFS. So if you want to use NFS file system, you have to deploy NFS gateway on them. So by accidentally, I have done that in the last class, which is not required. And similarly, these things are the Cloud Data Management Service related process: alert publisher, event server, host monitor, reports manager, and service monitor. So it is just to provide information in a concise manner. And JT is for job tracker, and TT is for task tracker. Okay, so I have chosen the job tracker on a different node than name node and master name node. In a typical production cluster, your two masters should not be running on the same node. Okay, if that is the case, then there will be many side effects because of that. It is not that you should not, they will not enforce you to run or not to run on a particular node, but it is not a good practice in production clusters. But in development and test clusters, it is typical to run a name node and resource manager, job tracker on same node. But we are trying to simulate the production cluster, so we are having the job tracker, which is master for data processing on a different node, which is 04. Click on continue, and now it is actually asking you to for a couple of directory locations for logs and other stuff. You leave them as default. Typically, you will have a different mount point for these things, and you will mount to this location, and then you can customize the names for this. These are primarily for intermediary data while processing the data, and also for log files. And then hit continue, and now it is starting the MapReduce service. So it is done. The service is started. You can hit continue and click on finish. It is running, but because there are some internal issues, it is showing up this error. Probably it could be MySQL issue or Cloud Data Agent issue. I think it is most likely MySQL issue. That's why it is coming and going away. In this case, SDFS seems to be up and running, and even MapReduce is up and running. Job tracker health is good, and even task tracker health is good. Okay. Now we have set up the cluster. We have set up the slaves. We have set up the masters. Again, here also this heartbeat comes into picture. task tracker sends frequent heartbeats to job tracker, and also it sends information about resources and usage to job tracker as part of heartbeat. So similar to data nodes to name node, task trackers will send the information to job tracker. Okay, and the parameter file for MapReduce is MapReduce.xml, and the name node is important for even to run the map processing jobs, which are MapReduce jobs, because without connecting to name node, it cannot get the mapping between the files and blocks. So the MapReduce.xml, that's where CoreSite.xml will provide the information to. Let me show you, then I will explain. So I'm going to let me see whether the actually I have, yeah. So let me go to one of the task tracker clusters, task tracker nodes. So in this case, let me go to 509. Okay, and the password is Hadoop 20. And as I mentioned to you earlier, the actual parameters will be under VAS1, Cloudera SCM agent, and process, and LSLTR. And this is the location where you have to see, or you can even check this location. But the deployed client configuration is more important than this one. Okay, CD89, LSLTR, Hadoop conf, LSLTR, and you can see the MapReduce.xml. Okay, and CoreSite.xml and all these parameter files will be in the same location, HDFS site, CoreSite, and MapReduce. So CoreSite.xml will actually provide the information of name node to the job tracker. So you will not see name node information in this. Okay, the first parameter is job tracker, and this is the IP address of the job tracker, and 8021 is the port where job tracker process will be running. And then there will be many other parameters. HTTP address is for UI, so we can actually do this one, 504. Similar to 50070 for name node web UI, 500, what is the port number? 30 is the default port number for job tracker. I have to give HTTP in the beginning. And if you hit enter, so it will show you the job tracker UI. Okay, so it seems to be running. Now we will run a MapReduce job, and then we will understand what it is actually and how it works. Okay, that comes under validation. So we spoke about MapReduce.xml parameter, and these are the important parameters. What happened? Okay. So these are the important parameters. Job tracker is the one which will tell what your job tracker is, and 8021 is the default port number. And the job tracker HTTP address is for the web UI, which we have seen. System directory, MapReduce system directory is HDFS directory to store MapReduce control files. And the local directory is to store intermediate data files. I will explain that local directory in a moment. And then the task scheduler, by default it is FIFO, first in, first out. But typically we will use pair and capacity. We will talk about the schedulers on Sunday class. And the queue names. So actually there is a concept of queue which is tightly coupled with the scheduler, and we will talk about that as well as part of that class. And then there are many other parameters like how many map tasks should be running on a given task tracker, how many reduce tasks should be running on a given task tracker, how many MapReduce reduce tasks should run for a job. So there will be some parameters that will be controlling, and that will be defined at task tracker level, and there will be parameters that are defined at job level. So MapReduce task is the parameters at the job level, and the other two parameters, task tracker map tasks and task tracker reduce tasks, are the examples for the parameters that are defined at task tracker level. So if you understand the hierarchy, job tracker, task tracker, and the job, there will be parameters at each level. So the first two are the examples of job tracker, and these two, which have task tracker in them, are at task tracker level, and then MapReduce tasks are at job level. Okay. So now let me run a sample job on the data we have copied. Okay. Let me go to gateway node. Which one is the gateway node? Yeah, this is the Hadoop 20 and Hadoop jar. Okay. So Hadoop jar is the command to run the MapReduce job, and there are examples that are provided as part of the setup itself, and they are even available with plain vanilla Hadoop without any distribution. But the names are always changing. So before validating, they are called as examples jars. So before validating, you should identify where those jar files are, and for that again you can run the command of sudo find. Okay, and I'm starting from OPT because I know that the jars of cloud distribution are laid out under /OPT. So instead of searching the entire file system, I'm limiting my search to OPT. So recursively in that location, I'm searching for the example jar files, and I can give -name to search by name, and the naming convention is, even though they change the versions, the naming convention will follow this. Hadoop examples, there will be Hadoop and examples in that jar file name, and star is for the pattern matching. So anything which have Hadoop and examples in the jar file name, I want to search for those files. So I think it is not OPT, it is etc probably. Let me do this. Okay, it's under user lib. Okay. So in this case, you should not. You can pick any of the examples to validate our purpose. I'm picking this one. Okay. So Hadoop jar. Hadoop jar, and this is the jar file name. And when you actually first, let me do this. Let me jar TVF. TVF is to list all the classes that are part of this jar file name, and then let us see what all we have. So user Java. Okay. Bin. So jar TVF. So there are a bunch of class files here, classes here, and there is a class called word count. So if you want to run a word count program, you can do that. And there are a bunch of them. Okay, but you can in this case you should not use the class names directly. What you have to do is Hadoop jar and give the jar file name and hit enter, and it will help you what all you can do. So in this case, there are plenty of programs. One is word count. So if you want, so it uses manifest files behind the scenes. So non-Java developers don't worry about it much. Just run Hadoop jar and give the jar file name, for example, jar file. And once you see the list of these things, whatever you want to use to validate, just use them to validate. Most likely, either you will run word count program or random writer. What random writer will do is, for each data node, it will generate a 10 GB data. So there is a logic behind the scenes. So it will, as it generates 10 GB of data for each random, for each node. If you run the random writer program, it will tell you whether your cluster is properly configured or not, and then you can delete the data once it is validated. But it will take time to generate that much data. So instead of using that, I will be using word count program on my 2 GB file, which I have copied earlier. It's a large deck of cards. So the word count program typically search words by using space as delimiter. But in my case, I don't have spaces in my program. So each line will be treated as one word. And so indirectly, I'm computing the number of records in my deck of cards. Okay. And developers will create jar file, and either you have to schedule, if you are admin, either you have to schedule them using cron or some other enterprise scheduler tool. But typically, either you or even there will be application support teams in the larger organization. So either admins or application support teams will take care of scheduling the jobs. But administrator will not build the jar files. It will be provided by the developers, whether it is application support or core admins who take care of the cluster. They have to get the jars from the developers with the instructions of how to schedule them if admins have to schedule them. Okay, in this case, I am doing work on program, and the input path is user, HD user, and large deck.txt. And I have to give the output path. So user, HD user, output, word count. Okay. I mean, if you want, you also can log into the name node. But when you give the output path, just a suffix, you can copy this, and then at the end you just suffix with some unique identifier, so that because if everyone uses the same output path, it will fail. The job will fail, saying that directory already exists. So you have to give a unique directory. In my case, I am giving BM, which stands for Big Data Mental. Similarly, you can use your first initial and last initial to run this command. Okay, BM, and I am running the program. Okay, the job is running, and let us see what is happening on Job Tracker UI. Okay, I think it is running in local mode. So yeah, it is running in local mode. So the deployment, I think the gateway node did not get the configuration deployed. So for now, what I will do is I will use the job tracker node itself to submit the job rather than running from the gateway node. So let me copy it. So in case if you want to run, log into 504 node, not on the gateway node. This is an issue which you should be able to fix as an administrator. Typically, ideally, you should be able to submit, all the jobs should be submitted from the gateway node itself. In this case, we didn't configure the gateway properly, which I will address it. Once I start the job, when it is running, I will try to address it. Okay, if you want to run, instead of 500, go to 504. And then run the job. It might fail because directory already exists. So let me delete the directory. Hadoop SSRM -R. Now let me Now it is running the job, and if I refresh it, you can see on the job tracker what is going on. And before getting into the running jobs, if you go through the entire web page, you will get a lot of details about your cluster. You will get the cluster capacity. There are 8 nodes. You can click on that. It's a link, and you will see what is going on. And there are the capacity to run mappers in this cluster is 8. So there can be only 8 mappers in the cluster at any given point in time, and there can be only 8 reducers in the cluster. And we can increase that number. We will see that in later. But this page itself will give a lot of information about your cluster. And now we have a job that is running. You can click on the job, and there are already 15 jobs are 15 tasks are completed, and 2 are running. So this job is divided into 17 mappers to process the data, and then 4 reducers. We will see about it later. But this is where data locality comes into picture. Okay, and if you actually go to the counters, even there is a count. I will explain what counters is in the next class. So one of the important thing you need to look at is data local map tasks, and they should be close to 100%. So there are 17 mappers, and all the 17 mappers are local map tasks. I will explain what the local map task is and why it is significant and all those things in the next class. But this is how you can run a MapReduce job, and you can monitor from the cluster. So I will recommend everyone to run the job now and see how it is running, and ask me any questions on this, and then I will try to resolve it. This is how you submit the jobs. So developers will give the jar files, and also they will provide the framework to copy the data into the cluster. As administrator, sometimes you have to copy the data, and most of the times you have to schedule the process provided by developers in the cluster. You will not be developing anything, and they have to not only give the jar files, they also have to provide the instructions, developers. Okay, so that is about validation. It is running properly. You can run those things in a moment. And now coming back to OS commands, as we have seen in HDFS, here also you can run ps-su command. MapReduce process will be owned by a user called MapRed, and if you see, there will be a process that will be running in the backend. So we are on the master node. That's why we are seeing job tracker. If you are on the slave node, you will see task tracker. Okay, so from OS level, this is how you can actually validate whether the daemon processes are running as expected or not. Okay, and using Cloud Manager, as I have shown you earlier, just go to Home and click on MapReduce, and it will give you all the information. You can use Cloud Manager also to validate. And then logs. Again, logs are go to cd sudo su root cd var log lsldr, and for MapRed, this is the location. Okay, and you can see the log files for your MapReduce programs. So as this is master, you will see job tracker. If it is slave, you will see task tracker in the log file names. And again, you can go to configuration in this, and you can search for log.dir, and this is the one which will control level log file location. Okay, so I will explain actual framework, how it will work a little bit in detail on Sunday's class. For now, try to run the MapReduce job. Yes, so if you have to process the data, you have to you have to give a program. Okay, so so Jar file is nothing but a program. They are nothing but compiled Java classes, and they will have the logic. So in this case, we are trying to run a word count program, which is nothing but a Java program behind the scenes, and it will the default the actual logic in word count is if you have a program like if you have vi test.txt, and if you have hello world, how are you doing? And if you want, so what word count program will do is it will process each line using space as delimiter, and it will consider each word as a yeah. Good night, Raj. We are almost done, so you are good as long as you understand what we have done today. So what word count program will do is it will pass each and every word, and it will give you the count of the word. In this case, each word repeated once, so you will get hello one, word one, how one, all one, you one, doing one, etc. In our case, we are trying to get the count of the cards. So let me review the output. So in this case, what I'm trying to do is by passing the jar file and passing word count as a parameter, I'm trying to run a program behind the scenes. So I have passed my large deck as input to the program, and the output will be returned to HDFS. Large deck is in multiple blocks on different nodes, so it will read from all nodes. Yeah, that's what I will explain the entire logic on Sunday's class. We are almost close, and it will take time to explain that, and I will take care in Sunday's class. Okay. For now, just understand how to submit jar files, and also try to familiarize with the job track UI, and then we will discuss about the flow in Sunday's class. Okay, I will give some time, run the program, and while you are running, I will I will give a few more details about parameters, and then we will wrap up for today. Okay, even what I'm trying to say in configuration in parameters is, if we look at job tracker, okay, now the capacity is 8 mappers and 8 reducers, okay. And depending upon the nature of applications you run in the cluster, you might have to tweak these things. You might have to configure your cluster with more mappers than reducers. So all these things can be controlled by modifying parameters in the file. And also we have 8-node cluster, and we have only 8 mapper capacity and 8 reducer capacity. But we can increase the capacity based upon the resources, the number of CPUs we have, and the amount of memory we have. Okay, and the way you will do it is by running ls CPU command. So we have 2 CPUs on each of the node in the cluster, and yeah, there are 2 CPUs. And also, if you run the top command, ls CPU gave me the number of CPUs per cluster, per node. And then memory is almost 4 GB. I should have more. Why it is showing 4 GB? It should have 7.5 GB. I'm not sure why it is only showing up as 3.7 GB. Probably I might be using the low end ones. Okay, so depending upon the memory and CPUs, you should be able to tweak this thing. So as I have 2 CPUs, actually the best the thumb rule provided by Cloudera or Hortonworks or even Apache Hadoop is to configure 1.5 times of the capacity. So in this case, we have 8 nodes and each one have 2 CPUs. So the capacity is 16. So the mapper capacity and reducer capacity together should be 24. That is the thumb rule which applies for most of the scenarios. So we can increase this, and I want to increase the map capacity to 16 and leave the reduced capacity as it is. So I want to go to the parameter files, go to configuration, and here MapReduce or MapRed dot map dot. Yeah, this is the one. I want to reset to 2. Yeah, I want to reset to 2 and then save changes. Click on home. And then you can redeploy the configuration. So it is showing the difference, and restart the cluster. It will take little time. Check the redeploy client configuration and restart now. Okay, finish. It is done. Now if I refresh, the map capacity is 16. Okay, so based upon the resources, when the jobs are running with maximum capacity, you should run the top command and other monitoring commands, and you can play with this. By default, you can use the thumb rule of 1.5 times of the number of cores on each node in the cluster. But still, in some cases, it might not use all the resources. So you can play with it. You can sometimes give double. You have to come down. So you have to monitor the cluster for a few days until you get to the ideal number, and then you can finalize the number. So you have to follow a little bit trial and error to finalize the capacity on the cluster, to finalize your mappers and reducer capacity when you are using Classic. When it is Yarn, it is a different story. We will see it in the next class. So that is about the configuration and all. Let me see if I have anything that needs to be covered. So yeah, so verifying logs, we have seen how to verify the logs. And coming to logging, there is something called log4j properties. For now, just understand that you use log4j to configure the properties, and I will cover it later. Okay, I have already explained about the web interface, a little bit about job tracker. This one will take time, so we will see it later. Okay, so that's it for now. I will give 5 more minutes. You can run the job